One of the challenges when interacting with a data source, especially a remote data source, is reducing the amount of information we have to send back and forth. When we talked about using data transfer objects and the JSON view annotation to deliver filtered subsets of data to our front end, we retrieved some entity data that we didn't need. It wasn't very much in our examples, but you might encounter situations where entities are very large and the amount of information you need is rather small. One way we handle this is through something called projections. Projections allow us to write queries that populate objects which are not entities. We can use them for things like looking up a favorite composer by person ID, getting the list of all hats in our outfit database, or combining data from two unrelated entities into a single object. Let's look at an example. Say we want to feed a REST endpoint that gets called frequently, and all it does is return the full list of all favorite composers chosen by any person entities. We certainly don't need to fetch the entire list of people to do this, so our query will only return a list of strings by selecting one attribute from an entity instead of the whole object. This is called a single column projection. We'll make a new typed query of the type string and then use select distinct p.favoriteComposer from person p and specify the return type as string.class. We can now get a result list that just has the list of favorite composers. This sort of simple projection is easy and helpful, but sometimes we want to select multiple fields and create a new object to hold them. This is called multiple column projection and can even return columns from joined tables. We can use multiple column projection to populate any non-entity class directly from a query or through the use of Criteria Builder. For example, perhaps we just want to return someone's name and favorite composer. We'll make a class called personComposerDTO with the attributes name and composer. In order to populate a projection within the query, we also need a constructor that takes these parameters so we can instantiate it with the columns we select. Now, we'll make a query that returns a new instance of personComposerDTO. Note that we need to use the fully qualified name of the class in order to do this. When this query returns a result, it gives us an instance of personComposerDTO. Since this is not an entity, it will not be managed by the entity manager and is simply a POJO. While projections are an extremely useful tool for reducing the size of our queries, try to avoid designing around them. Consider splitting data into multiple entities instead of creating large, monolithic entities that require frequent projection. Divide your data into multiple entities that are related to one another, which enables Hibernate to take advantage of lazy loading. This means you can query for entities without populating all the data of their associated objects unless you need it. Consider our person class and the outfit data. The information about our outfit is not directly included in our person class, because that would deprive us of the ability to execute outfit-specific queries without using a projection. It also allows us to query for person entities without retrieving outfit data. If you have a lot of projections, it may mean that your database design differs significantly from your application needs. Hibernate does recommend projections for read-only transactions because it's faster, but it ties our data layer to the display and adds complexity to the data layer by making multiple objects that can represent the same data. That's all we'll be covering on projections here, but you can find more information about them and how to use those operations with the Criteria Builder in the Hibernate documentation.